What is hiding at the edge of the solar system where the light slowly fades and the oldest memories of the universe still drift in silence? The Oort Cloud. The final boundary of the solar system where an invisible ocean of ice exists, where time seems to stop, and where every comet begins its journey back toward the light. It is not only a physical structure, but the memory of the universe itself, preserving the story of creation, destruction, and rebirth. A whisper that proves even in stillness the universe is still breathing. Right now, let us slowly step beyond the boundary of light, to listen to the secrets that sleep within the Oort Cloud and the edge of the solar system. Closest to the Sun, worlds spin in steady harmony. Mercury, Venus, Earth. Mars, small islands of rock carved by heat and history. Between Mars and Jupiter lies a field of stone fragments of an unfinished world, the asteroid belt. To the human eye it might seem crowded, but in truth it's a vast emptiness, where millions of rocky bodies float, each separated by millions of kilometers of silent distance. Beyond Jupiter, the gas giants rise. Their gravity sculpts the shape of space, bending it like wind-shaping dunes. Saturn with its rings of frozen glass, Uranus tilted in its sleep, Neptune dark and restless at the edge. And then just beyond begins the Kuiper Belt, a ring of icy debris 30 to 50 times farther from the Sun than the Earth. Here light weakens, shadows stretch longer. The Sun becomes not a disk, but a pale star among many. The Kuiper Belt is the last boundary we have truly seen. It's a realm of frozen relics, Pluto, Eris, Haumea, remnants from the time before planets found their balance. Each of them spins slowly, their surfaces scarred with the marks of time and cosmic frost. But even this distant ring is not the end. It is merely the edge of what we know. Farther out, scattered bodies drift into an even colder domain, the scattered disk. Here the pull of the Sun grows faint like a voice fading in fog. The orbits of these bodies are stretched, elongated, unpredictable like forgotten memories, returning once in 1,000 lifetimes. And through this region humanity has sent its messengers. Voyager 1 and Voyager 2. Tiny metal seeds flung into the dark more than 4 decades ago. They carry music greetings and hope, etched onto golden records for any who might listen beyond the stars. Voyager 1 now sails at 168 astronomical units from the Sun, farther than any human creation has ever travelled. That is 25 billion kilometres, and yet, still within the reach of the Sun's invisible hand, still part of its ancient family. We often say that Voyager has left the solar system, but scientifically that isn't quite true. It has only crossed the heliopause, the border where the solar wind yields to the interstellar medium. Beyond that boundary, sunlight no longer rules, but gravity still whispers. The Sun's influence extends much farther into realms we cannot yet see. If you close your eyes now, you might imagine this invisible ocean. You are Voyager adrift in the endless tide of plasma and dust. Every hour you move 1,000,000 kilometers farther from home. Behind you, all of human history shrinks to a single glimmer of blue light. Ahead, the unknown unfolds, silent, cold, infinite. And somewhere in that unknown, perhaps 2,000, maybe 5,000 times farther than Earth is from the Sun, begins a mystery. A cloud. Not a cloud of vapor or storm, but of ancient ice and memory. It surrounds the solar system like a forgotten halo. Scientists call it the Oort Cloud. We have never seen it. No telescope has ever caught its light. Yet its possibility feels undeniable, like the presence of wind in a still forest known not by sight but by touch. It may be the true boundary of our cosmic home, the frontier where the solar system dissolves into the galaxy itself. If that is so, then everything we've known, the planets, the moons, the asteroids, the Kuiper Belt, are only the inner courtyard of a far larger structure. Beyond them lies something vast and uncertain, a sea of frozen fragments orbiting in slow, patient silence. And tonight, as you breathe slowly and feel the rhythm of that silence settling around you, remember this. The further we drift from the light, the closer we come to understanding what still waits to be discovered. Out there beyond Neptune's faint blue orbit, the Sun no longer feels like a blazing presence. It becomes a point, small, distant, almost fragile, and through that fading light a traveller continues to move. Voyager 1. Launched in 1977, its golden record still turns slowly inside its metal shell, a human heartbeat sealed in silence. Every day it drifts another 1.5 million kilometers farther from home, It carries no destination, no expectation of return, just the pure motion of curiosity. Scientists once said that Voyager had left the solar system, but truth as always is quieter than headlines. It hasn't left the sun's kingdom, not yet. What it crossed was the heliopause, the invisible border, where the solar wind fades and the breath of interstellar space begins. Here, atoms from distant stars mix with the last sighs of our own star's outflow. This is not emptiness. It's a sea of particles, delicate and slow, each one whispering of collisions that happened long before Earth formed. Inside that vast gradient of pressure and light, Voyager's instruments still hum faintly. They read cosmic rays, magnetic fields, plasma waves, the subtle fingerprints of the galaxy around us. The data it sends home now takes more than 22 hours to arrive, a single transmission crossing billions of kilometers before it touches the antennas of Earth. By the time we hear its signal, the spacecraft has already moved on. If you listen carefully to recordings of those plasma vibrations, you can almost hear a tone, a soft, drawn-out note like wind through glass. That's the music of the interstellar medium played across a billion-kilometer harp. Some scientists convert it into audible sound. They call it the voice of Voyager. It is perhaps the loneliest song ever made. Think of the distances involved. At 168 astronomical units from the Sun, Voyager 1 has travelled 25 billion kilometres, farther than Pluto, farther than any comet we have tracked. Yet compared with the suspected reach of the solar system, it has only stepped onto the shore. If the inner planets were the heart of a city, Voyager is still wandering the suburbs, its lights flickering against the cosmic dusk. Beyond it lies a region so large that even imagination struggles. Scientists estimate the inner boundary of the Oort Cloud might begin around 2,000 to 5,000 astronomical units, dozens of times beyond Voyager's current path. At its outer edge, one might travel 1.5 light-years before reaching the faint pull of another star, Proxima Centauri. For Voyager to arrive, there would take 300 years just to meet the inner edge, and 30,000 years to reach the farthest rim. By then, continents will have shifted, languages will have changed, and the memory of the probe may exist only as myth. Still, we imagine it continuing its antenna, tilted its body coated with the dust of time, moving through a space where the sun's warmth is just a number in a memory file. Every photon of sunlight there is a survivor of distance, stretched and weakened until it becomes indistinguishable from the glow of other stars. The solar system dissolves into a field of light, and the line between inside and outside blurs. When Voyager crossed that boundary, we crossed something deeper than physics. We stepped beyond the comfort of our maps. The gravitational hold of the sun still ties us to home, but our reach, our will to know, extends farther. It's as if humanity leaned out over the edge of its own existence, whispered what's next, and listened for an answer in static. In the years since newer probes have followed new horizons, sailing past Pluto, still transmitting, still alive. But even these explorers are bound by time. Their power fades, their instruments sleep, and someday they too will drift unmonitored through the interstellar dark, carrying fragments of us, a map, a greeting, a hope. It's a thought that makes astronomers quiet during long nights at the console. They know each signal could be the last, a final heartbeat from a machine built in the age of analog, and yet in that quiet, there's something tender. Because even if Voyager never sends another word, its path has already spoken. There is more beyond the known. There is always more. So when you close your eyes and breathe with the rhythm of the void, imagine following it past the frozen Kuiper belt, through the scattered dust into the realm where sunlight ends. You're travelling beside Voyager, now carried by the same invisible momentum. In front of you, darkness thickens but does not frighten. It invites. Each heartbeat slows to match the rotation of distant ice. And somewhere in that perfect stillness you begin to feel the pull of something vast and unseen. A presence waiting beyond the light, the first whisper of the Oort Cloud. Somewhere beyond the faint hum of Voyager's signal, imagination takes the place of observation. There in the vast stretch where sunlight no longer reigns begins the first true leap of hypothesis. Scientists call it the Oort Cloud, a theoretical sphere of frozen debris surrounding the solar system like a shell of ghosts. It's an idea born not from sight but from necessity. For centuries, comets puzzled astronomers. They appeared suddenly glowing, developing tails that stretched across the sky, then vanished sometimes, not to return for thousands of years. If these comets were bound to the sun, their orbits had to come from somewhere far beyond the planets, beyond even the Kuiper belt. The math insisted on it, and so slowly a new frontier began to take shape in human thought. a reservoir of ancient bodies drifting at unimaginable distances, each one a silent messenger from the birth of the solar system. We have never seen this cloud directly. No telescope has caught even one of its members in orbit out there, yet every long-period comet that falls toward the Sun brings with it a trace of evidence, its speed, its chemical signature, its trajectory. Each of these clues points to a distant, unseen origin. Like footprints in fresh snow, they suggest a presence just beyond our reach. Astronomers speak carefully when describing this realm. They don't call it a fact, but rather the best explanation for what we observe. The Oort Cloud is not a discovery. It is a deduction, an elegant solution to a cosmic mystery. If comets are the wanderers, then the cloud is their homeland. Picture it for a moment, a sphere so vast it could stretch halfway to the nearest star. Within it, trillions of icy fragments orbit in darkness, moving so slowly that an entire human civilization could rise and fall before any of them complete a single revolution. Some are no larger than mountains, others the size of small cities, their surfaces coated with ammonia, methane, and frozen water. They reflect almost no light black glass drifting through a black sea. The inner part of this cloud scientists think may not be truly spherical. Instead, it could be slightly flattened, shaped by the lingering influence of the giant planets. But farther out, gravity evens out in all directions, and the shape becomes round an invisible bubble, marking the limit of the Sun's power. Beyond it, other stars begin to pull more strongly than our own. In a sense, it is the border of our cosmic citizenship, the point where the solar system gives way to the galaxy. It's humbling to realize that every spacecraft humanity has ever launched, every signal ever sent, has so far remained inside that invisible wall. Voyager 1, heroic, unstoppable, is still hundreds of times closer to the Sun than the cloud's suspected inner edge. Our entire technological reach, all our ambition, has so far covered less than 1% of that distance. What we call interstellar travel is in truth only a gentle step into the outer hallway of our own home. And yet, despite never seeing it, astronomers can describe this region with remarkable precision. They know how far its gravity might extend. They can estimate how long sunlight would take to fade there, and how faint its reflection would be. They even speculate about the total mass of the cloud, perhaps a few times the mass of Earth spread thinly across a space so large that the average distance between objects could be 50 million kilometers. In that emptiness, each comet is a solitary traveler. Still, questions remain. If it exists, how did it form? Was it sculpted by the newborn sun's gravity, flinging leftover ice and dust outward, like sparks from a fire? Or did passing stars help shape it, tugging at the edges of the early solar system, mixing our debris with theirs? Perhaps every star carries such a cloud, a memory of its own beginning. The Russian astronomer Ernst Upik first proposed this idea in 1932, but it was Jan Oort in 1950 who gave it form and evidence. By studying the orbits of long-period comets, he noticed a strange pattern, a clustering of aphelia, the farthest points of their paths, at a consistent distance from the Sun. It was as if these comets were emerging from the same great distance, falling inward under the faintest whisper of gravity. Oort's conclusion was simple but profound. There must be a vast unseen cloud of icy bodies surrounding the solar system, the reservoir from which new comets are occasionally dislodged and sent sunward. Every comet we observe today, each luminous visitor that graces the night sky, is a message from that invisible frontier. When its orbit curves toward the Sun, it begins to evaporate, shedding tails of vapor and dust that glow briefly before fading again into the dark. These comets die young and quickly. Their persistence across billions of years implies one truth: there must be a place continually sending them to us. So even though we cannot see the Oort Cloud, we can feel its influence in every returning comet, in every mysterious arc of ice that crosses the void. It is both real and unreal, unseen yet mathematically alive in our models, logically required by the dance of gravity itself. And that is where science meets wonder. Sometimes the universe reveals its truths not through sight, but through pattern, through the delicate geometry of motion. The Oort Cloud may be invisible, but it leaves fingerprints everywhere. Each comet is a letter written in the language of orbits, and when we learn to read it, we discover not just where we are, but how small and beautiful the boundaries of our knowledge truly are. In the stillness beyond the planets, where the sun's warmth fades into shadow, we enter a place that exists only as an idea, the Oort Cloud. It is not a world nor a ring, but a veil of possibility, a structure so immense that language itself struggles to contain it. Scientists describe it as two regions, one slightly flattened, the other perfectly round, both made not of light but of absence, an architecture of ice distance and memory. If we could see it, the view would defy the senses. Imagine a sphere so vast that it stretches nearly halfway to the nearest star. The inner zone, perhaps beginning 2,000 astronomical units from the Sun, might extend to 20,000. There the Sun is no more than the brightest of many stars in a black endless firmament, and beyond that lies the outer halo, a true sphere reaching to 100,000 AU, or even 200,000, where the solar system dissolves into the galactic tide. To understand its size, think of this: all the planets, all their moons, the asteroid belt, even the Kuiper belt itself. Everything we have ever seen fits inside a bubble that is just 1/100th of the Oort Cloud's imagined volume. The entire solar family becomes a speck suspended in a cold, luminous fog of ancient fragments. These fragments, icy worlds, frozen stones, are leftovers from the earliest days of the Sun. Long ago, when the solar system was young, gravity gathered gas and dust into a bright disk around a forming star. Planets' condensed orbits stabilized, and what remained was scattered outward far beyond the gravitational comfort of the planetary realm. Some of those exiled fragments found peace drifting into the deep, where the Sun's pull weakened but never disappeared. They became citizens of the unseen, the first inhabitants of the Oort Cloud. Each object moves in its own silent ellipse, tracing a journey that may take millions of years. From our perspective, their paths overlap in all directions, forming a vast celestial cocoon, not dense, not crowded, but delicate. If you could stand on one of those icy surfaces and look around, the nearest neighbour might be tens of millions of kilometres away, invisible in the dark. The space between them is so great that the Oort Cloud is more empty than any vacuum we can create on Earth. And yet this emptiness holds history. These are not random rocks. They are fossils, time capsules from the solar system's creation. Each carries in its composition the chemical code of an era when the planets were still molten and chaotic. Water, methane, ammonia, carbon compounds the very elements that would one day nourish life on a blue planet far within. It is possible that the same icy seeds that drift through this cloud once fell inward, as comets bringing oceans to the Earth. If the Oort Cloud exists, it is more than a boundary. It is the memory of origin preserved in cold storage. Its structure, though theoretical, has logic. The inner region, shaped by the planet's early gravity, may retain a flattened disc-like form. The outer region, sculpted by galactic tides and passing stars, rounds into symmetry, a spherical ocean of relics. Two shapes, two histories, one invisible harmony. You could think of it as the solar system's aura, faint, transparent, but immense, a cosmic halo of potential. Even though it cannot be seen, its effects can be inferred. Long-period comets fall toward the Sun not randomly, but from every direction in the sky. Their even distribution tells us that they come from a roughly spherical source, far beyond the plane of the planets. That is the fingerprint of the outer Oort Cloud. And inside that shell, perhaps closer to us, may lie the Hills Cloud, a denser intermediate layer that acts as a reservoir feeding comets inward. Some researchers suggest that this region holds the majority of the Oort Cloud's mass. If true, it is a hidden ocean of ice waiting patiently for disturbances, a passing star, a tidal wave from the Milky Way, the gentle tug of gravity to awaken it. Now pause for a moment. Imagine drifting at that distance, thousands of times farther from the Sun than Neptune. Light takes hours, even days to reach you. The Sun itself would appear no larger than any other star. Around you, silence. No warmth, no colour, only the faint pressure of starlight from the Milky Way wrapping around your frozen world. Here the laws of motion slow almost to meditation. Every orbit becomes an act of patience measured not in centuries but in epochs. This is the architecture of the Oort Cloud, theoretical, elegant, invisible, and infinite. It reminds us that science often begins not with what we see, but with what we infer. Every equation, every model, every quiet diagram drawn in the dim glow of a computer screen is an attempt to imagine this unseen cathedral of ice. It is both real and unreal, both physics and poetry, a place where certainty ends and curiosity takes over. Perhaps one day our descendants will send a probe that far a machine built not to return, but simply to confirm that the silence has shape. Until then, the Oort Cloud remains our most beautiful mystery, a sphere we believe in, a horizon we cannot touch, a boundary where imagination and science finally meet. In the deep ocean of darkness that surrounds the Sun, the smallest fragments of ice become the oldest storytellers. They are the frozen seeds of memory, silent and unbroken, drifting through the Oort Cloud like ancient pages of a forgotten book. Each one carries a signature, a trace of hydrogen, carbon, oxygen, the same ingredients that once composed the first raindrop on Earth. They are older than the continents, older than life, perhaps even older than the planets themselves. If we could reach one of these fragments, chip off a corner of its ice and study it under light, we might see the chemistry of beginnings. Inside the transparent shell would be water frozen for 4.5 billion years, preserving gases from the Sun's infancy, even whispers of interstellar dust that predates our solar system. That means every comet that falls inward, every glowing traveller we see from Earth, is not just an object. It is a time capsule, a message from the cosmic dawn. Scientists believe that these bodies, small and scattered, helped shape the young Earth. When comets bombarded our planet in its violent youth, they delivered the ingredients for oceans, for atmosphere, for the first molecules of life. Each impact was both destruction and creation. Fire followed by rain heat, followed by cooling chaos giving birth to chemistry. It's poetic to think that the water you drink today may once have drifted for billions of years in the Oort Cloud waiting for its turn to fall. And yet, for all their ancient patience, these icy relics are fragile. When drawn toward the Sun, they awaken suddenly. Heat cracks their shells, gas bursts outward, and a coma forms a luminous veil of vapor and dust stretching thousands of kilometers. That is the beauty we see through telescopes, a moment of brief radiance before decay. The comet burns not in defiance, but in revelation, revealing its inner self to the universe before fading again into darkness. In the quiet of space, each of these awakenings begins far from home. A slight nudge, the passage of a nearby star, the gravitational pulse of the Milky Way may disturb the delicate equilibrium of an Oort Cloud body, and like a leaf caught in a slow invisible current, it begins to drift inward, tracing a long ellipse toward the center of light. Thousands of years later, it will pass close enough to the Sun for us to see it, its tail unfurling, its nucleus glowing, a fragment of the farthest frontier greeting its maker once more. These comets are the proof that the Oort Cloud, though unseen, leaves fingerprints across time. Each one is a messenger returning from the edge, carrying the mineral and molecular memory of where it came from. When we observe their composition, the ratio of isotopes in water, the presence of ammonia or organic carbon, we find signs that match the deep space chemistry of the early nebula. That's how astronomers know these objects did not form in the heat of the inner solar system. They were born cold, and they have remained cold ever since. And in their stillness they record the rhythm of creation. When they fall inward, it's not random. Their paths follow the distribution of a vast invisible reservoir that surrounds us completely. We see comets arriving from every direction in the sky, north-south, above and below the ecliptic, as though the solar system were being softly rained upon by its own outer halo. That symmetry is not coincidence. It is geometry speaking the language of probability. It tells us the Oort Cloud must be real even if unseen. If you imagine drifting among these icy bodies, you would see none of them glow. They do not shimmer or pulse, they simply float ancient and waiting. The light from the Sun would be too faint to reflect, too weak to define shape. Only instruments sensitive to heat 1 billion times fainter than a candle could trace their presence. And yet each one holds within it the story of temperature, pressure and dust that once surrounded the infant Sun. Some scientists even speculate that hidden among them may be bodies of rock, not ice at all, remnants of shattered worlds, flung outward in the solar system's chaotic youth. In 2021, a meteorite found in Canada contained isotopic ratios suggesting it had come from such a distant reservoir, a rocky emissary, from the Oort Cloud itself. If that's true, it means the cloud is not just a home for frozen fragments, but a mosaic of origins part solar, part interstellar, a mixed archive of everything that has ever touched our gravitational field. Every theory about the Oort Cloud carries this quiet awe that something so immense and unseen can still leave marks everywhere in the chemistry of water, in the periodic arrival of comets, in the faint statistical hum of their trajectories. It's as if the solar system keeps a diary written not in words but in orbits, and the Oort Cloud is the cover that holds those pages together. Now, as you imagine yourself suspended within that invisible ocean, feel the serenity of it. No motion is hurried here. Each particle drifts on a timescale that ignores the heartbeat of life, the ticking of clocks, the rise and fall of civilizations. time itself becomes gentle. The silence around you isn't empty, it's full of patience. Every comet, every icy grain, every molecule of methane is waiting for its moment, maybe a billion years from now, to fall inward and shine for a heartbeat. And when it does, perhaps someone somewhere will look up from a blue planet and whisper its name, not knowing that the light they see began as a frozen seed of memory, waiting since the beginning of everything. Far beyond the last pale shimmer of Neptune's orbit lies a darkness so deep that light itself becomes hesitant. Here the sun's warmth is a rumour, a memory of fire that can no longer be felt. And somewhere in that vast uncertainty drifts what we believe to be the Oort Cloud, unseen, yet necessary, silent, yet persistent in every calculation. If it is truly there, then it is not hidden out of mystery, but because physics itself conspires to keep it invisible. The first reason is simple distance. Even the inner edge of the Oort Cloud is at least 2,000 times farther from the Sun than Earth. That means the sunlight there is not merely dim, it is 100,000 times weaker. An object coated in ice at that distance reflects less light than the faintest known dwarf planet. For a telescope on Earth, it would be fainter than the faintest whisper. No reflection, no shadow, no trace. Even if a mountain-sized body were floating there, its glow would be lost among the random flickers of background stars. The second reason is motion, or rather the lack of it. Out there, gravity's leash is long and loose. Each orbit stretches across millions of years. A single object may move so slowly across the sky that even after a decade of observation it appears still. Modern surveys rely on change, a dot, that shifts between photographs, a subtle migration of light. But the Oort Cloud moves too slowly to reveal itself. Its inhabitants glide in near stasis, patient beyond comprehension. Even our best technology is bound by the limits of light. The most sensitive infrared telescopes can detect the heat of asteroids in the inner solar system, but the bodies of the Oort Cloud are colder than cosmic background radiation. They do not emit enough warmth to be seen. They blend into the temperature of the universe itself. They are not just far away, they are thermodynamically invisible. It's humbling to realize that despite everything humanity has built, we are still blind to the outermost reaches of our own system. Our spacecraft Voyager, Pioneer New Horizons, are infants in comparison to the distances required. Voyager 1, the farthest of all, is still hundreds of years from the cloud's inner edge. By the time it reaches that region, if it ever does, it will be long silent, its power exhausted, its voice faded into background static. Some researchers have proposed searching for indirect evidence, faint gravitational anomalies, in the orbits of distant trans-Neptunian objects, or tiny perturbations in the trajectories of comets returning from the deep. These subtleties might whisper of unseen masses like footprints on invisible ground. But so far the data remains ambiguous. What we know is less a photograph and more a pattern of absences, an outline of what should be there. The Planet 9 hypothesis offered a glimpse of how difficult such searches can be. If a planet several times the mass of Earth could remain undetected at just a few hundred astronomical units, what chance do we have to see fragments scattered thousands of times farther? Taish, another proposed world, perhaps a gas giant dwelling 15,000 AU from the Sun, was once imagined to explain comet paths. But years of infrared scans found nothing. No light, no heat, no Taish. Only the cold persistence of mystery. And yet, that mystery holds power. It reminds us that our instruments measure not only what exists, but what we allow ourselves to look for. The Oort Cloud may not be invisible by nature. Perhaps it is only waiting for us to invent the right eyes. A telescope launched far beyond Pluto, cooled to near absolute zero, could someday detect the delicate glint of sunlight off a frozen body 1 trillion kilometers away. For now, that remains a dream. But dreams are how astronomy begins. Even our mathematical models struggle with the vastness. To simulate the motion of trillions of objects over billions of years is to push the limits of computation itself. Physicists approximate, simplify, reduce the swarm to equations of probability, a haze of potential locations and velocities. In that statistical fog, the Oort Cloud takes shape not as a map, but as a possibility field. It exists as much in the language of numbers as in the cold expanse of space. Philosophically, there is something exquisite about this invisibility. The Oort Cloud teaches us that belief in science is not blind, it is disciplined imagination. We infer existence through consequence, through coherence, through what must be true if everything else is to make sense. We have never seen an electron, yet we know its charge. We have never seen the Oort Cloud, yet we trace its breath in every comet's return. The unseen does not diminish reality, it completes it. Imagine for a moment standing at the edge of this darkness. You look back toward the sun, and every planet, every known thing is now condensed into a single point of light. You're outside the realm of sight, inside the realm of inference. There is no colour here, only texture, the faint hum of cosmic rays, the gravitational murmur of unseen motion. And as you drift, you realise something profound. The Oort Cloud is not hiding from us. It is simply too large, too subtle, too patient to fit into our narrow window of time. We are creatures of decades. It is a structure of eons. Our telescopes blink for minutes. Its orbits breathe over millions of years. And yet somewhere in that immense mismatch between our perception and its existence lies the quiet lesson of astronomy. The universe does not reveal itself when we demand it. It reveals itself when we are finally ready to listen. So when you close your eyes tonight, imagine the unseen not as empty but as full of everything we have not yet learned to observe, full of all the truths waiting in the cold. Because even in its silence, the Oort Cloud is speaking in gravity and mathematics, in the faint rhythmic arrival of comets from the dark. And maybe one day, when our patience matches its own, we will finally see the invisible and call it home. In the quiet gulf beyond Neptune, there lies a question that hums like a low frequency through the void. If the Oort Cloud truly exists, if it surrounds us like an unseen sphere of frozen time, why can't we see it? It is a question that sounds simple, yet stretches deep into the philosophy of observation itself. For most of human history, to see was to believe. Light defined truth, but in astronomy, light is only the beginning of knowing. And here at the very edge of the sun's domain, light itself begins to fail. The first paradox of the Oort Cloud is not its scale, but its silence. Objects that far from the sun reflect so little light that even the most powerful telescopes would need to stare for years to collect a single photon. The intensity of sunlight decreases with the square of the distance, a law that turns brilliance into near blackness. At Earth's distance, the sun warms oceans and paints skies. At Pluto's, it becomes a faint cold glow. At the Oort Cloud's inner rim, 2,000 astronomical units away, sunlight is a ghost. Each icy body there receives less than a millionth of the light that reaches Earth. For all practical purposes, the sun is just another star in the sky, and that simple reduction in brightness ripples outward into impossibility. A telescope relies on contrast, on distinguishing one pattern of light from another. But the background of deep space filled with stars, galaxies, and the faint whisper of the cosmic microwave background is far brighter than any Oort object could ever be. The cloud doesn't shine against the dark, it dissolves into it. The universe hides its edges not with walls but with sameness. Yet we know it must be there. Every comet that arrives from the farthest distances follows a trajectory that begins in that vast sphere. Their orbits, when traced backward, converge not on the Kuiper belt or the scattered disk, but on a boundary thousands of times farther out. In that invisible frontier, gravity and sunlight balance in perfect tension, a region where the sun still holds dominion just barely. To imagine such distance, we must think in scales that defy comfort. One astronomical unit, the measure from Earth to Sun, is about 150 million kilometres. Voyager 1, our farthest emissary, sits at roughly 170 AU. The Oort Cloud's inner edge then begins at 2,000. Its outer edge may lie at 100,000. That's a sphere so large that even light would take nearly 2 years to cross it. And across that space, a trillion frozen relics drift, like invisible embers, each one too dim, too small, and too slow for our eyes to detect. When astronomers attempt to simulate this region, they face another paradox motion so vast that it becomes stillness. At such enormous distances, an orbit can take millions of years to complete. From our perspective, those movements are frozen. They change so slowly that no generation of humans, perhaps no species of humans, would ever see them shift. To witness the Oort Cloud in motion would require patience longer than civilization itself. In a sense, our blindness is not technological but temporal. We cannot see what does not move quickly enough to register within the span of our existence. The universe operates on time frames we can calculate but not experience. The Oort Cloud reminds us of this cruel, beautiful truth that some knowledge exists only for those willing to wait in geologic time, and yet astronomy is built on such waiting. We cannot touch the stars, but we can infer their births from spectra and their deaths from light curves. We cannot hold the Oort Cloud in our hands, but we can read its signature in the way comets arrive in their angles, their speeds, their compositions. Each is an echo, a ripple sent from that frozen frontier. We may not see the stones themselves, but we see the songs they send us. Still, the mind resists. To accept the existence of something unseen requires a leap of surrender of certainty. It demands that we replace the comfort of vision with the rigour of inference. It is both scientific and spiritual, because beyond a certain distance, faith and physics begin to sound the same. Imagine standing on a distant comet's surface deep in the Oort Cloud. You look toward the sun, but it is no longer a source of light. It is a bright star among countless others, flickering weakly through the cosmic haze. The Milky Way arches overhead a frozen river of stars, beautiful but cold. The silence is absolute. Even the concept of day has disappeared. Here, illumination is internal, not from the sun, but from the awareness that you are still somehow bound to it. That gravitational tether, invisible, unbroken, extends more than a light year into space. It is the reason comets return. It is the reason the Oort Cloud exists. The sun's reach, though faint, never truly ends. Every particle, every ice crystal drifting in that outer sea is still dancing to its pull. They are beyond warmth, beyond visibility, but not beyond belonging. So perhaps the real paradox is this. The Oort Cloud is invisible, not because it is absent, but because it is everywhere, a diffuse halo of matter, so vast that no instrument can frame it. We are inside it right now, cocooned in its outermost wisps, surrounded by an ocean of dark glass and frozen dust. We are looking outward from within the very thing we cannot see, and maybe that's the quiet revelation of the Oort Cloud, that sometimes the reason we fail to perceive something is not that it's too far away, but that it includes us. We are part of the mystery we are trying to measure, bound by the same gravity, made of the same dust, waiting for the same light to return. They call it Planet 9, a ghost of mathematics, a whisper at the edge of calculation. Not seen, not proven, but suspected. A heavy presence haunting the outer darkness. It began with motion. Far beyond Neptune, astronomers noticed that certain icy bodies, the trans-Neptunian objects or TNOs, moved in strange synchrony. Their orbits tilted in similar directions, their farthest points clustered together, as if drawn by an unseen hand. The pattern was too precise to be coincidence. Something massive, perhaps 5 or 10 times the mass of Earth, seemed to be tugging on them from the dark. But where telescopes swept the sky searching, infrared surveys scanned millions of stars. Nothing. No glow, no reflection, no signature of heat. And yet the gravitational clues refused to vanish. The equation still required a cause. Thus was born the myth of Planet 9, a world hidden in plain sight, orbiting far beyond the Kuiper belt, perhaps 1,000 astronomical units from the Sun. In a way, Planet 9 became the modern echo of an older mystery Tyche, the supposed gas giant once believed to lurk at the edge of the Oort Cloud itself. Back in the early 2010s, some scientists suggested that the cloud's comets might be disturbed by such a planet, an unseen guardian or trickster depending on the story. But the data was thin, the evidence vanishing. NASA's infrared sky survey saw no trace of a body that large. Tyche was dismissed, its name left to mythology. And yet, like so many ideas in astronomy, it refused to fully die. In every unaccounted perturbation in every comet arriving at an odd angle, the question lingered. What if something massive really is out there waiting to be found? It's easy to see why the idea captivates. We've mapped nearly every major world inside the solar system. We know the shapes of their orbits, their moons, their rings. But to imagine an undiscovered planet a true wanderer at the frontier is to taste the same wonder that once led Galileo to turn his telescope toward Jupiter. It reminds us that completion is an illusion. Every time we think the solar system is finished, the universe adds one more line to the story. Still, the numbers are merciless. If such a planet exists at those distances, sunlight would be 1,000 times weaker than at Pluto. Its surface, if solid, would be colder than liquid nitrogen. Its orbit might take 10,000 years to circle the Sun, once so long that no civilization could track it from beginning to end. And from Earth, its reflected light would be dimmer than the faintest galaxies our instruments can see. It would be a world made of gravity alone, detectable only through the tremors it leaves in the dance of others. That is the poetry of modern astronomy. We no longer find new worlds by looking, we find them by listening. The music of orbits, the rhythm of perturbations, these are the clues. When Neptune was discovered in 1846, it too was first detected not by sight, but by the subtle distortions in Uranus's motion. Mathematics pointed the telescope. Now, nearly 2 centuries later, mathematics does the same, again pointing into a void beyond imagination. And in that void lies the borderland between the known solar system and the hypothetical realm of the Oort Cloud. If Planet 9 exists, it may serve as the bridge, a cosmic intermediary that shapes the outer debris stirring comets from dormancy, injecting them toward the inner sun. Its gravity could sculpt the very architecture of the Oort Cloud's inner layers, the way a distant moon stirs the tides of a faraway sea. But there's a deeper fascination at work here, the psychology of unseen things. The idea that something vast can remain hidden so close just beyond our perception humbles the modern mind. In an age when we can map galaxies billions of light years away, how can we still be blind to a planet that might share our sun? The irony is cosmic distance disguises more effectively than obscurity. A single astronomical unit difference in orbit makes Mercury glow like a flame. 1,000 makes Planet 9 vanish into arithmetic. Perhaps that's why the search endures not just as science, but as philosophy. Planet 9 represents the frontier that moves with us, the shifting boundary between knowledge and speculation. To look for it is to admit that the map of our home is still incomplete. It reminds us that mystery is not a flaw in understanding, it's the engine of it. There's a certain beauty in the thought that the solar system might have one last world circling in silence, unseen by any human eye. Imagine it a frozen sphere wandering through eternal twilight, its horizon lit only by the scattered stars of the Milky Way. Perhaps it has moons, perhaps rings of dust, perhaps nothing at all, but the slow churn of methane snow. Its orbit would tilt steeply, its velocity gentle, its loneliness absolute. For every 1,000 years of Earth's history, it moves only a few degrees along its path. To it, time is syrup. To it, we are a brief flicker in the glare of a forgotten star. And yet, even if Planet 9 is only a mirage of math, its idea performs a function. It keeps the imagination awake. It teaches us that absence is not emptiness, and that science is strongest when it confesses uncertainty. The unseen planet, whether real or not, is a reminder that discovery often begins as a question whispered into darkness. Perhaps the Oort Cloud too was born this way, not from sight, but from necessity, from a pattern too coherent to ignore. In that sense, Planet 9 and the Oort Cloud are twins of speculation. One planetary, one collective, both invisible, both inferred. They are the echoes of gravity itself, subtle distortions that prove something exists, even when the eyes cannot. So when we gaze into the dark and ask whether such a world awaits us, we are not just seeking another planet. We are seeking reflection, confirmation that the unknown still has room to grow. And maybe somewhere in that vast perimeter, where our sun's gravity fades into the galactic tide, a cold planet really is circling now unseen and unhurried, its path intersecting the edge of the Oort Cloud, its shadow brushing the frozen seeds of ancient comets. An unspoken reminder that even after 4.5 billion years, the solar system is still writing itself one hidden orbit at a time. Our eyes were made for dawns and firelight, not for the deep geometry of darkness. Even with our most powerful telescopes, we still see the universe as through a narrow window, one that catches only a sliver of what truly is. Beyond that window lies the realm of the Oort Cloud, where light fades into meaninglessness, and human perception begins to dissolve. This is where astronomy humbles us. The universe does not exist at the scale of our senses. It unfolds in magnitudes and times far beyond what we can grasp. The limits of sight are not failures of technology. They are reminders of biology, of who we are and how fragile the act of seeing has always been. On Earth, our eyes evolved to track motion, to read colour, to measure survival. We can perceive the warm glow of sunlight, but not the faint whisper of infrared. We can sense contrast between shadow and flame, but not the invisible structure of gravity. To the universe, we are infants crawling through light. And the Oort Cloud, in its perfect stillness, lives beyond even that faint awareness. Even the great observatories Hubble Spitzer, the James Webb, cannot find it. Their mirrors are tuned for the brilliance of galaxies, the heat of nebulae, the afterglow of creation itself. But the Oort Cloud emits no heat, no glow, no reflection. Its bodies sit near absolute zero, radiating less energy than the cosmic background that fills the rest of space. It is not dark in the way a cave is dark, it is dark in the way silence is silent. Complete, balanced, absolute. And so we try other ways of seeing. Mathematics becomes our telescope, gravity our lens. Through orbital mechanics, we trace invisible curves deducing the presence of mass where no light exists. We map what cannot be seen through the subtle changes in what can. Every comet returning to the sun is like a beacon in reverse, not a light shining outward, but a shadow moving inward, revealing the shape of the void from which it came. This is how modern science perceives the imperceptible. We listen to the universe rather than look at it. We analyze vibration velocity and time delay, small signs of the vastness behind them. When Voyager 1 sent back its final images, its cameras captured nothing but scattered stars. And yet in those pixels hidden behind the wash of data was Earth the pale blue dot, as Carl Sagan called it. A point of light barely a fraction of a pixel wide. That is all we are even in our own solar system, a tiny pulse of colour in a sea of invisible mathematics. If that is how small the Earth appears, imagine how a single comet nucleus hundreds of billions of kilometres away must vanish completely. The only way to know it exists is to believe in the physics that predict it. That belief is not blind. It is disciplined faith, the kind that builds bridges across the unknown. Astronomy lives on such bridges. But sometimes in the long hours of night, astronomers allow themselves a different kind of vision. They picture what the Oort Cloud would look like if we could see it. Not as a sharp structure, but as a vast haze, a faint translucent halo shimmering around the sun. A glowing breath extending across a light year of space, the sun floating at its centre, like a lantern inside a frozen mist. Every star would have its own similar halo overlapping with others, until the entire galaxy became a tapestry of invisible clouds touching at their edges. The Milky Way then would be a web of memory, each thread a record of how worlds were formed. There's something profoundly human in this act of imagining what can't yet be proven. For millennia we've looked into darkness and given it shape. Once it was gods and myths, now it is data and probability. But the instinct is the same, to bring order to wonder, to name what cannot be touched. In that sense, the Oort Cloud is not just a scientific hypothesis, it's a mirror reflecting our nature. We create models of the unseen because we cannot stand the thought of a universe that is entirely silent. Yet the silence is not indifferent, it's patient. The Oort Cloud doesn't hide from us. It simply exists on a different scale of time. Its motion is too slow, its light too faint, its essence too cold for our present tools. But it waits as it has always waited, through the birth of species, through the rise and fall of civilizations, through the steady blooming of curiosity. It waits for a moment when we will look again, not with eyes, but with understanding deep enough to match its stillness. So when we speak of the limits of human sight, what we really mean is the beginning of another sense, the sense of inference, of reason, of imagination guided by evidence. It is the way a blind traveller reads a landscape through the sound of his own footsteps. It is how we know the Oort Cloud, not through the light it gives, but through the stories it tells in gravity's quiet voice. And one day, perhaps a new generation of explorers will drift past the edge of light, their instruments cooled and silent, listening instead of seeing. They will not photograph the Oort Cloud. They will feel it. They will measure its presence by the gentle tug on their ships, by the density of dust that brushes their hulls, by the subtle shimmer of starlight refracted through ancient ice. They will confirm what we already suspect, that the boundary of the solar system is not a wall but a whisper, and that the universe beyond is not emptiness but continuation. Until then, we watch the night sky and remind ourselves not everything that is real must be visible. Not everything invisible is unknown. The Oort Cloud exists not in the telescope's mirror but in the balance between certainty and wonder, a reminder that our eyes are small, but our imagination bound by reason can still reach the stars. They arrive unannounced, glowing against the black like living embers, comets, the messengers of the deep. For most of history, their appearance filled the sky with awe and superstition. But in truth, each one is a traveller from the outer frontier, a visitor from that unseen sphere we call the Oort Cloud. They are our only glimpses of that hidden world, crossing the boundary between hypothesis and sight. Every comet you've ever seen, every streak of light carved across the night sky, began its life in the frozen dark. There, billions of kilometres away, it lay dormant, an icy fragment smaller than a mountain, suspended in silence for millions of years. Then something changed. Perhaps a distant star brushed close enough to disturb the balance, or the gravitational tides of the Milky Way nudged the object from its slow orbit. Whatever the cause, the stillness broke. The frozen seed began to fall inward, pulled gently, then fiercely toward the sun. As it approaches the light, the transformation begins. The first heat seeps through its ancient ice-awakening gases that had slept since the dawn of the solar system. The surface fractures, releasing plumes of water vapor, carbon monoxide, methane, ammonia molecules formed before Earth was born. The coma forms a vast glowing halo of gas surrounding the solid nucleus. Then the tail, that unmistakable signature of a comet, streaming away as solar wind tears the vapor into ribbons of light. What we see from Earth is not the comet itself, but its exhaustion, the beautiful death of something that has travelled too far. This is why comets are sometimes called time travellers. Their orbits carry them between epochs. Many were born when the solar system was young, their chemistry unaltered since that chaotic beginning. To study a comet is to study a piece of the past preserved in deep freeze and delivered to our doorstep by gravity. It is no wonder that the first spacecraft to chase one, the Rosetta mission, to comet 67P Churyumov-Gerasimenko, was named for the stone that unlocked ancient languages. Each comet is indeed a code, a script written in dust and ice. But comets also tell a deeper truth about balance and renewal. They are fragile. Every visit to the sun erodes them layer by layer. Most will not survive more than a few dozen orbits. Some disintegrate completely, scattering their remains across the paths of planets. And yet, despite their short lives, new comets keep arriving. Every century, dozens of long-period comets are discovered, their trajectories stretching beyond comprehension, some taking hundreds of thousands, even millions of years to complete a single orbit. They fall toward us, as if from nowhere. But nowhere in this case has a name, the Oort Cloud. It was the behaviour of these long-period comets that first convinced scientists the cloud must exist. Their orbits are randomly oriented, they come from every direction, not just the flat plane where the planets reside. That distribution can only arise from a roughly spherical source far beyond the disk of the solar system. In the mid-20th century, Jan Oort looked at this pattern and understood its meaning. If comets arrive from all sides, they must come from a vast surrounding reservoir. That realization turned a curiosity into a theory, and a theory into the quiet cornerstone of modern planetary science. Even now, the evidence continues to accumulate. We know that short-period comets, those that loop around the Sun every few decades, originate from the Kuiper Belt, a flattened region beyond Neptune. But the long-period comets, those that vanish for millennia before returning, bear orbital signatures that point to distances far beyond. Their aphelia, the farthest points of their paths, cluster around 50,000 astronomical units. That is the scale of the Oort Cloud. When they fall inward, they do so from the solar system's outermost edge, bringing with them the chemistry of another realm. And so when a comet suddenly appears in the night sky, it is not an omen, but an echo. An echo of formation, of instability, of distant perturbations that happened long before humanity existed. It is the system breathing, exchanging material between its deep cold and its inner warmth. Each comet that burns across the heavens is part of that long conversation between center and periphery, between memory and motion. When you see a comet, you're witnessing a rare alignment of time and space, a reunion between the sun and something it cast away eons ago. The gravitational bond never truly broke. It merely stretched across the dark, and every return is a reminder that even in the farthest cold connection endures. The Oort Cloud is not empty, it is a waiting sky, a slow heart still beating at the edge of light. In ancient civilizations, comets were thought to carry messages from the gods. In a way, they still do. But now we understand that the message is written not in prophecy but in isotopes and orbits. They tell us about the temperatures of creation, the mixing of molecules, the symmetry of motion. They tell us that the solar system was never static. It was born in scattering and migration in exchange, and that scattering gave birth to the cloud, the great unseen ocean from which these icy messengers come. So as you picture one streaking across the velvet of night, know this: its light is ancient, but its journey is ongoing. When its orbit carries it back into darkness, it will sleep again for ages, circling silently around the sun. And somewhere out there, trillions of its kin drift in the dark, waiting for another disturbance, another chance to fall inward, and briefly become visible, a flicker of proof that the invisible still moves, that the Oort Cloud is real, not as myth, but as memory. Every comet that graces our sky carries a countdown within it. Its light, however brilliant, is a temporary flare, a cry against entropy. When the ancient astronomers watched these bright wanderers appear and fade, They imagined them as omens, fire-tongued messengers of fate. They were right about one thing: every comet is in a sense a warning not of doom but of impermanence, because comets cannot last forever. Each journey toward the sun consumes them grain by grain, molecule by molecule. When their frozen shells heat up, the volatile gases trapped within escape, forming the dazzling coma and the trailing tail that make them visible. But beauty here is erosion, the slow unravelling of something impossibly old. One pass through the inner solar system can strip away meters of ice. Dozens of orbits can reduce a comet to rubble, a faint cloud of dust spreading invisibly across the vacuum. This is the paradox of the comet. They are ancient relics, yet every visible one is newly awakened. If they had all existed since the birth of the solar system, every last one would have already perished. And yet they keep coming. Their luminous deaths must be fed by an unseen source, an enormous reservoir continually resupplying the inner solar system with fresh material. That reservoir, we believe, is the Oort Cloud. Jan Oort saw the problem clearly in 1950. He calculated that the observed population of long-period comets could not possibly have survived for billions of years without a constant influx of newcomers. Something must be sending them. Somewhere far away, a vast halo of icy bodies must be storing the seeds of these visitors, occasionally disturbed by gravitational tides, stellar flybys, or even passing molecular clouds. And so the Oort Cloud was born not as a discovery but as a solution, a necessary symmetry to balance the books of cosmic decay. Over time, this reasoning grew stronger. Astronomers realized that the rate of cometary appearances matched what one would expect if the cloud were real, a trillion dormant nuclei scattered across a light year of space, each waiting to be dislodged. When a comet is torn from that vast reservoir, it begins a long, slow fall that might last millions of years before it ever nears the sun. For every one, we see thousands more wander unseen through the deep night. But the cloud doesn't merely release comets, it also consumes them. Some are lost forever, ejected into interstellar space by planetary encounters. Others collide with planets, moons, or the sun itself. In this eternal circulation, the solar system breathes loss, balanced by renewal, destruction, balanced by discovery. It is a fragile equilibrium held together by gravity and time. To understand just how fleeting a comet's life is, imagine one that circles the sun every few hundred years, like Halley's Comet, whose path takes about 76. Each time it returns, a little more of it vanishes. Astronomers estimate that Halley will survive perhaps another 10,000 years, a blink compared to the age of the solar system. Then it too will fade, becoming a stream of dust and gas invisible to any telescope. Its particles will continue orbiting, forming meteor showers, until even they disperse. What remains afterward is memory, a story written in starlight, erased by time. This impermanence may sound tragic, but it is also deeply poetic. The same forces that destroy comets are the ones that make them visible. Without sublimation, without disintegration, they would remain forever dark. Their beauty depends on their fragility. In that sense, they are the perfect metaphor for knowledge itself, shining only when they are consumed. From a scientific view, the short lifespans of comets serve another purpose. They allow us to estimate how often new ones must arrive from the Oort Cloud. By measuring how many are destroyed per century, we infer the size and activity of the invisible source. Each disintegrating comet is a data point in the ledger of the unseen. It tells us not only that the Oort Cloud exists, but that it is alive, dynamic, evolving, continuously exchanging matter with the inner solar system. Yet there is another layer more philosophical than physical. Comets are the solar system's most fleeting phenomena, but also its most enduring connection to the past. They are reminders that nothing survives unchanged. Planets may persist, but even they drift, cool, and decay. The Oort Cloud itself will one day disperse under galactic tides, its contents stolen by passing stars. Everything falls apart, but in falling apart, new worlds are born, new paths carved, new questions asked. So perhaps it's no coincidence that comets, these fragile dying travellers, have so often been seen as harbingers, not of catastrophe but of continuity. They embody the paradox at the heart of existence, that the transient and the eternal are bound together, that what fades is also what reveals. Every time a comet burns, it tells the same story the universe has told since its beginning. To exist is to change, to shine is to be undone. And so when we look at the Oort Cloud not as a static archive but as a living engine of renewal, we see it differently. It is not a cold, dead halo of frozen relics. It is a cosmic, lung-breathing comets into the solar system, and exhaling dust back into the dark. It is the rhythm of return, the quiet assurance that even in the deepest cold motion never ceases. Perhaps that is why comets move us, why even now in the age of data and precision, we still step outside to watch them streak across the sky. For a brief moment we see something that connects our small human timeline with the infinite cycles of creation and decay. We see what it means to endure by transforming to live, by returning to illuminate by vanishing. And in that realization we understand the Oort Cloud is not just the source of comets, it is the source of remembrance, a reminder that every spark of light, however fleeting, comes from a darkness that never stops giving. They are not just wanderers, they are witnesses. Every comet that crosses the inner solar system carries within it a memory and unbroken record from the dawn of time. Long before Earth had oceans, before Jupiter had moons, before the planets even settled into their paths, these frozen archives were already forming, collecting dust and molecules from the swirling nebula that once surrounded the newborn sun. When we study a comet, we are looking at a time capsule. Its nucleus, a mixture of ice rock and organic compounds, has remained almost unchanged for over 4.5 billion years. While planets underwent volcanic convulsions, atmospheres and impacts, comets slept in cold isolation. They remember what the solar system has forgotten. The Rosetta mission was the first to read that memory directly. In 2014, after a 10-year journey, the spacecraft arrived at Comet 67P Churyumov-Gerasimenko. What it found was a world both alien and familiar, a surface of cliffs and plains, jets of gas bursting from fissures and molecules older than Earth itself. Among them, glycine and amino acid, one of the essential building blocks of life. That single discovery deepened an ancient suspicion that the seeds of life might have come from the sky. This hypothesis, known as panspermia, suggests that comets could have delivered organic molecules and perhaps even prebiotic chemistry to the early Earth. The idea once seemed bold, almost mythic, the notion that life began not from within but from beyond. But as more missions sampled cometary material from stardust to deep impact, the evidence accumulated complex carbon chains, alcohols, simple sugars, all frozen into the icy dust. The early solar system was not a sterile machine, it was a chemical garden, and comets were its gardeners scattering seeds across empty worlds. Yet the story they tell is not just biological, it is architectural. The composition of a comet reveals where it was born. Some contain crystalline silicates materials that could have formed only in the warm regions near the young sun. Others are rich in volatile compounds that could survive only in the deep cold. This means that somehow matter was exchanged across vast distances in the early solar system, warm and cold materials mixing, colliding, scattering outward. The Oort Cloud then is not a simple shell of leftovers. It is a mosaic, a grand archive of every region the solar system once occupied. Each cometary nucleus is like a page from that cosmic manuscript. By analysing their isotopic ratios, scientists can read the history of temperature, radiation and pressure in the solar nebula. Deuterium to hydrogen ratios, for instance, tell us how water condensed in the earliest days. Some comets share water signatures similar to Earth's oceans, others do not. Together they outline a complex story, one in which Earth's water might be partly homegrown, partly imported, delivered by billions of impacts from icy messengers. That story is written not only in chemistry but in motion. Each comet's orbit carries clues about the gravitational encounters that shape the solar system. Some trajectories suggest they were flung outward by Jupiter or Saturn during the system's chaotic youth, trapped by the sun's gravity at immense distances. Others may have been captured from nearby stars as the sun drifted through its birth cluster. In either case, every orbit we trace is another line in a story that spans billions of years and countless collisions. If we could gather every comet and map its origin, we would see a pattern of incredible beauty, a spiral of matter radiating outward, freezing then falling back again. The solar system is not a static model. It is a living memory, and the Oort Cloud, its great archive, in the same way that ice cores on Earth preserve the record of ancient climates, the Oort Cloud preserves the geological and chemical memory of the sun's birth. It is the final vault of cosmic history untouched, waiting for us to read it. But there is a strange irony in this archive. To learn from it, we must destroy it. When a comet approaches the sun, its pristine surface sublimates, and its oldest material is lost in the glare. Every observation, every sample is an act of erasure. We learn from what disappears. Science often works this way, illumination paid for in loss. The act of knowing changes the thing known. Still, there are plans to preserve rather than burn. Future missions, perhaps robotic probes launched on trajectories that intercept long-period comets, could collect samples before the sun alters them. Others dream even further spacecraft propelled by solar sails or nuclear engines that could reach the inner rim of the Oort Cloud itself. There beyond the heliopause they could study the untouched relics directly reading the earliest pages of our system's formation. Such a mission would not just explore distance, it would explore time. Philosophically, the comets remind us that memory is both fragile and eternal. They endure only by falling apart, yet in doing so they reveal the past. Their sublimation is a confession, the act of letting go so that we might understand. In that way, they are mirrors of our own curiosity burning themselves away to give us knowledge. When you watch a comet, you're witnessing the solar system remembering itself. Each trail of light is a memory dissolving into the present, a translation of history into brilliance. And behind every one of them, unseen and patient, the Oort Cloud waits, holding the rest of the pages still unread, still untouched. It is perhaps the most ancient library in existence. No walls, no shelves, no caretakers, only silence, distance, and the slow, steady orbit of ice through the dark. And within that silence lies the answer to where we came from, and maybe how life first began to glow. Out there at the edge of everything we can call home, the universe is never still. Even the farthest particles, those icy wanderers drifting in the black calm of the Oort Cloud, are not beyond influence. They sleep, yes, but it is not a perfect sleep. Every so often, something stirs them. The Oort Cloud is a structure balanced on the knife edge of gravity. The sun's pull holds it together, but only just. At such distances, tens of thousands, even 100,000 astronomical units, the sun's authority begins to fade. Beyond that thin boundary, the gravitational tides of the Milky Way begin to whisper. Stars pass nearby, interstellar clouds sweep through, and the galactic field flexes like an invisible tide. Each small ripple can send one of those frozen relics drifting inward, breaking its eons-long stillness. This is the mechanics of disturbance, the great unseen conversation between the solar system and its cosmic neighbourhood. The Oort Cloud, though bound to the sun, is also sculpted by the galaxy. Its comets are like seeds in a gravitational wind, sometimes pushed away, sometimes drawn in. When that balance shifts even slightly, a new visitor begins its slow fall toward the inner light. To understand how delicate this system is, imagine the Oort Cloud as a shell of dust surrounding a lantern. The lantern's glow, the sun's gravity, keeps the dust suspended, but the smallest breeze can send particles drifting outward or inward. Those breezes are galactic forces, the passing of a nearby star, the shifting density of interstellar gas, or the slow rhythmic pull of the Milky Way's own gravity. The stellar encounters are among the most dramatic. Every few million years, another star passes within a light year or two of the sun. It might seem distant, but on a cosmic scale that is dangerously close. Its gravity reaches out like a hand tugging gently at the outermost comets, changing their paths by fractions of a degree. Sometimes that is all it takes. A few dozen of those nudged objects begin long plunging journeys inward. Millions of years later, they arrive in the skies above Earth as new comets, the first visible signs of an encounter long past. One such event may have already left its mark on us. Astronomers believe that Gliese 710, an orange dwarf star about 60 light-years away, is moving directly toward the solar system. In about 1.3 million years, it will pass within just 10,000 astronomical units, right through the outer Oort Cloud. When it does, it will shake that distant ocean of ice like a stone dropped into still water. Thousands of comets will be dislodged, some flung into interstellar space, others falling inward toward the sun. For millennia after, the inner solar system may experience an era of bright skies, a storm of comets cascading from all directions. It will be beautiful and perhaps dangerous. But not all disturbances are stellar. Some come from the galaxy itself. The solar system moves through the Milky Way like a ship through waves. The gravitational field of the galaxy compresses and stretches everything it touches. As we orbit the galactic center every 225 million years, this gentle pressure rhythmically squeezes the Oort Cloud. Over time, that slow motion acts like a cosmic tide pulling on its outer edges, loosening comets from their ancient orbits. It is a reminder that the Oort Cloud is not a static boundary, but a living interface between our solar system and the wider cosmos. Even the invisible structures of the galaxy, the great spiral arms, the dark matter halo, may play their part. When the solar system passes through denser regions of the Milky Way, the gravitational balance shifts again. Some scientists even speculate that periodic increases in comet impacts on Earth might align with these crossings. Perhaps the rhythms of the galaxy leave faint geological echoes on our planet, subtle layers of catastrophe and renewal written in stone. To think of it this way is to understand the Oort Cloud not as a mere reservoir, but as a membrane. It is where the inner solar system breathes with the galaxy, where outside forces leave their faint fingerprints on the orbits of dust and ice. Through that boundary matter and energy exchange hands, sometimes slowly, sometimes in bursts. It is a cosmic shoreline constantly reshaped by unseen tides, and those tides can be beautiful in their precision. Consider the galactic tide acting like a pendulum's pull, constantly but gently altering the inclinations of the comet's orbits. Over eons, these shifts randomize their paths, giving the Oort Cloud its nearly spherical form. No single event created that symmetry. It is the cumulative result of billions of tiny gravitational whispers, each one imperceptible but together forming a pattern as grand as the galaxy itself. This interplay between the local and the cosmic, between the sun's fragile hold and the galaxy's vast tide, tells us something profound about connection. Nothing, not even the most distant ice, exists in isolation. The Oort Cloud is a meeting point of forces, a slow ballet choreographed by stars we will never see. When a comet appears in our sky, blazing through the upper atmosphere, we are not just witnessing the sun's power, we are witnessing the Milky Way's touch made visible at last. Perhaps that's why comets evoke such a strange awe. They are not intruders. They are reminders that our solar system is open to the universe. Every disturbance, every nudge, every fall inward is an act of communication. The galaxy speaks the Oort Cloud, listens, and across millions of years a message finally reaches us, a streak of light across the night saying, "You are part of this vast rhythm too." In this sense, the Oort Cloud is more than a boundary. It is the heart's outer pulse, a place where the gravity of our small sun meets the breath of the galaxy. And through that pulse, even the farthest darkness is in some quiet way alive. It is tempting to think of the solar system as a self-contained clock, a mechanism of perfect silent balance ticking in endless isolation. But that illusion fades once you look outward beyond the faint glow of the heliopause into the dark that belongs to the Milky Way. Their balance gives way to rhythm, and the Oort Cloud, that invisible sphere of frozen time, is not a static shell, but a participant in the galaxy's grand dance. Every star, every planet, every grain of dust in the Milky Way moves, in response to the same gravitational tide, an enormous slow breathing of the cosmos itself. The Sun and its retinue of planets orbit the galactic center once every 225 million years. That journey takes us above and below the galactic plane like a pendulum oscillating through regions of denser and thinner interstellar matter. Each oscillation brings change. Each crossing sends a subtle shiver through the Oort Cloud. These oscillations are the galactic tides. They are not tides of water, but of gravity and visible waves that compress and stretch the solar system's outermost boundary. The effect is delicate, almost imperceptible in human timescales, yet powerful over the ages. Imagine the Oort Cloud as a halo of 1 trillion frozen pearls surrounding the Sun. As the Milky Way's gravitational field flexes, those pearls shift slightly, a few are lifted outward, a few are drawn inward. Over millions of years, these tiny nudges accumulate into migrations, awakenings, and sometimes collisions. Astronomers model these tides like the ebb and flow of an infinite ocean. When the solar system moves closer to the galactic plane, the dense central layer where most of the galaxy's stars lie, the tides grow stronger. The outer Oort Cloud feels that pull most keenly. It is as if the whole halo leans slightly toward the galaxy's midline, releasing a handful of comets from its grasp. They begin their long descent inward, silent messengers, born from a rhythm so vast we can scarcely comprehend it. It is a cycle of stirring and silence. For tens of millions of years, the Oort Cloud drifts undisturbed. Then, as the solar system approaches another crossing of the galactic plane, the frequency of long-period comets increases. Some theorists have suggested that these tidal surges might even leave traces in Earth's geological record layers of impact. Craters' mass extinctions, sudden environmental shifts. It is not proof, only a pattern, but it whispers of connection, that life on Earth and death too may follow the rhythm of the galaxy itself. And the galaxy is not the only player. Passing stars occasionally brush close enough to deepen the effect, adding syncopation to the cosmic music. Sometimes they amplify the galactic tide, sometimes they cancel it. Each encounter is an improvisation unpredictable but inevitable. Even molecular clouds, vast and diffuse, can exert their own gravitational drag, like the passing of fog through a silent sea. The Oort Cloud feels all of it, registering every touch. Its comets are the sensors of the universe, responding to every faint vibration. Over billions of years, these tides have sculpted the cloud into its present form, roughly spherical, slightly distorted toward the galactic center. Computer simulations show that this shape is no accident. Without galactic tides, the cloud would have remained a thin disk like the Kuiper Belt. But with them, the orbits of its comets became randomized, spread across every angle. In a way, the galaxy's tides are both artist and archivist, shaping the cloud and preserving within it the memory of their dance. From Earth, this rhythm is invisible, too slow to observe directly. But if we compress time, imagine watching millions of years unfold in moments. The Oort Cloud would seem to ripple and breathe. Streams of comets would rise and fall like plankton in a tide. Occasionally one would break free, streaking toward the sun, not randomly, but as part of a deep repeating pattern. It is the solar system's heartbeat, pulsing once every few million years in synchrony with the galaxy's great orbit. For scientists, this long rhythm poses both beauty and danger. It connects celestial mechanics to cosmic history and possibly to the story of life itself. Some models suggest that periodic comet storms triggered by these galactic tides could deliver water and organics to young planets. Others warn that such storms could just as easily bring destruction impact events large enough to reset evolution. Thus, the Oort Cloud becomes a double-edged instrument, a bringer of genesis and extinction, both born from the same rhythm. To stand beneath the night sky and know this is to feel a strange kind of awe, not of vastness but of interdependence. The galaxy breathes, the Oort Cloud stirs, comets fall oceans, rise species, emerge and vanish. We are part of that cycle whether we know it or not. Even our existence, our chemistry, our oceans, our myths may be the byproduct of an ancient resonance between the sun and the stars around it. And yet, despite all its magnitude, this cosmic rhythm is gentle. It is not a violent storm but a slow waltz. Each beat takes 1,000,000 years. Each motion leaves its mark in gravity alone. If we could listen, if we could translate gravity into sound, the galaxy's music would not be loud, it would be low and deep like the hum of eternity. And the Oort Cloud, far from being silent, would be its softest chord resonating in time with the stars. So the next time you see a comet, that brief blazing wanderer streaking through our skies, remember that its journey began not with chaos but with choreography. It is the child of tides, the evidence of motion too vast to see. And as it burns across the heavens, what you're really witnessing is the Milky Way itself reaching out across light years to touch a single grain of ice, and through it to remind us that even in the stillness of the night, everything is dancing. In the deep quiet beyond the planets, gravity never truly sleeps. It murmurs a language without sound, a constant rearranging of motion. Every atom, every rock, every drifting shard of ice listens to those murmurs, and nowhere are they more subtle or more consequential than in the Oort Cloud. The comets that sleep there are not fixed. They drift in their long elliptical orbits for eons, moving so slowly that even light would call them still. But across cosmic time, stillness is an illusion. The cloud is a sea, and seas are never truly calm. Random encounters ripple through it, invisible yet inexorable gravitational whispers that rewrite destiny. A single passing star, perhaps one the sun once called a sibling, can change everything. Stars wander the galaxy like ships crossing in a dark ocean. Every few million years, one sails close enough that its gravity brushes against the outskirts of our solar system. It does not collide or capture, it simply nudges. But at those distances, a nudge is enough. One fraction of a degree in trajectory, one slight shift in orbital energy, and a comet that would have slept forever begins its fall toward the inner sun. Astronomers have traced this dance in simulations hundreds of thousands of years condensed into minutes of movement. You can see the pattern stars glide by, and the Oort Cloud ripples in response. Comets stir like leaves in a slow wind. A few drift outward, exiled into interstellar space. Others curve inward, tracing new ellipses that will one day cross the paths of planets. Each close encounter is a rewriting of the cloud's architecture. Over billions of years, it has reshaped itself countless times, molded by strangers passing through the dark. Sometimes those strangers come closer than we'd like. Astronomers estimate that the Sun has had thousands of stellar encounters within 2 light-years over its lifetime. Most were faint and harmless, but a few, perhaps a handful, passed close enough to send shockwaves through the cloud. Each time a rain of comets followed. Some never reached us, but others did, impacting planets, moons, and perhaps Earth itself. In their violence, they delivered both chaos and creation. Water, carbon, amino acids, the debris of destruction, became the ingredients of life. The next such encounter is already written in the cosmic schedule, Gliese 710, the orange star drifting closer with every millennium. When it arrives in roughly 1.3 million years, it will pass through the outer Oort Cloud like a silent intruder. No explosion, no flash, just a quiet gravitational push that will awaken a million sleeping comets. Some will be lost forever to the void. Others will begin the long fall inward, glowing centuries later in skies we will never see. The event will last millennia, yet it will begin in an instant, one whisper, one passing, one subtle distortion in the dark. But not all encounters involve stars. Sometimes even invisible masses pass through molecular clouds, rogue planets, or dark matter clumps drifting unseen. Each carries its own gravitational fingerprint. To the Oort Cloud, these are brief storms, unseen, unmeasured, but deeply felt. We may never detect the intruders themselves, but we can see their echoes, unexpected clusters of new comets, random deviations in known orbits, sudden asymmetries in the population map. The universe leaves traces everywhere, you only have to know how to read them. This interplay of chaos and order defines the Oort Cloud's evolution. It is not a perfect sphere, not even a consistent boundary. It swells and contracts with each encounter like the tide of an invisible ocean. Its density fluctuates, its edges fray, its contents mix with interstellar dust. At any given time, thousands of comets are being slowly ejected into the void, while thousands more drift inward to replace them. In this way, the Oort Cloud breathes not in air, but in orbits. To the untrained eye, this randomness might seem like noise, but look closely and a pattern emerges, a quiet equilibrium. The cloud may change shape, but it endures. It is self-healing like a living system. Every star that disturbs it leaves behind a new balance. Every loss is countered by capture, every ejection matched by replenishment. It is the solar system's most patient organism, adjusting to every tremor with grace. On philosophical terms, these encounters remind us of something profound, that even in the most distant reaches of our sun's influence, we are not alone. The boundary of the solar system is porous, a place where the inner and outer universe exchange stories. The Oort Cloud listens to the galaxy, and the galaxy in turn leaves its fingerprint there. It is not isolation that defines our home, but connection. If you could stand on one of those distant icy bodies, a lonely fragment 100,000 AU from the sun, you would feel this connection. The stars would no longer seem fixed. The constellations would shift slowly over centuries, their geometry altered by parallax and time. Every 1,000 years, the sky would subtly rearrange itself, not because of your motion, but because of theirs. Each star would glide along its own current, bending space and destiny as it passed. And though you'd feel nothing, your orbit would already be changing, rewritten by the gravity of strangers. That is the quiet truth of the Oort Cloud. It is not a fortress, but a field open, mutable forever, responding to the whispers of passing stars. It is the record of cosmic interaction, written not in words but in trajectories, and those trajectories in turn write the story of our own existence. Because without them, without those distant disturbances, the comets would never fall, and without the comets perhaps life itself might never have begun. So when we trace the origins of everything we are, we must look not only inward toward the Earth and the Sun, but outward, into the silence, to the random meetings in the dark, the gravitational handshakes between our small system and the wider sea of stars. In those invisible encounters, the universe reminds us that even its quietest gestures can change everything. In the beginning, there was only a disk, a swirling incandescent sea of gas and dust encircling the newborn sun. Within that luminous chaos, gravity began its long, deliberate work. Atoms clung to atoms, pebbles to boulders, boulders to worlds. Over millions of years, the solar system emerged from turbulence, a grand choreography of collision and order, creation and exile. But not all that was born of the sun remained near it. Some matter was cast away, flung outward by the very planets it had helped to create. Those exiles would one day form the Oort Cloud, a halo of memory surrounding the solar system, like a fossilized breath. No one witnessed its birth yet. The evidence is everywhere, in the chemistry of comets, in the orbits of distant objects, in the quiet logic of physics itself. To understand the Oort Cloud is to understand how the solar system learned to scatter, to expand, to shed pieces of itself into the dark. Its creation story is not one of construction but of dispersion. In its youth, the solar system was a place of violence. The sun, newly ignited, burned with flares that stretched millions of kilometers. Around it spun a thick disk of icy dust and gas dense enough to birth planets. Within this disk, regions of temperature and composition dictated what could form where, close to the sun, heat-ruled rocky planets took shape. Farther out, where the light was dim and cold, ices could survive, the realm of the giants was born. Jupiter was the first of those giants, massive enough to reshape everything around it. Its gravity was not gentle. It pulled in vast amounts of material, yes, but it also flung much of it away. Every small, icy body that strayed too close could be caught, accelerated and hurled outward like a slingstone. Saturn, Uranus and Neptune joined this gravitational symphony, scattering trillions of icy fragments into wild, elongated orbits. Some escaped the sun's grasp, entirely set adrift between the stars, but others did not escape. They slowed, curved, and remained loosely bound, falling into enormous elliptical paths that would take millions of years to complete. Those were the first citizens of the Oort Cloud. This process, known as gravitational scattering, is one of nature's most elegant contradictions. It destroys and builds at once. The same collisions and ejections that cleared the way for planets also populated the cloud that now defines the solar system's boundary. Without chaos, there would be no order. Without expulsion, no home. Over time, these scattered objects drifted farther and farther out until the sun's influence weakened to the whisper we measure today. There, in the slow tug-of-war between solar gravity and galactic tides, the cloud took its shape. The orbits of its comets were tilted, stretched, randomized, until the flat disk of the early solar system became a vast, almost spherical shell. It was the galaxy itself that sculpted it, each passing star, each distant tide smoothing its edges, blurring its symmetry, shaping the soft halo that now cradles the sun. In that sense, the Oort Cloud is a child of two parents born of the sun's primordial disk, but raised by the galaxy's hand. Half solar, half stellar, a hybrid structure that embodies the relationship between the local and the cosmic. Its existence blurs the line between our solar system and the space beyond. It is not inside or outside, but between the liminal region where belonging dissolves into infinity. And perhaps not all its members were born here. Some may be immigrants, captured debris from other stars. In the sun's early days, it did not drift alone. It was born in a cluster surrounded by sibling stars of similar age. Their gravitational fields intertwined, exchanging material like pollen between flowers. During those first 100 million years, the young sun might have stolen countless icy bodies from neighbouring systems, fragments that now rest quietly in our own Oort Cloud, unaware that they were born under another sun. They are the galaxy's adopted children woven seamlessly into the solar system's outer fabric. Thus, the Oort Cloud is not just a product of scattering, but of capture, a cosmic network of shared origins. It is the Milky Way's fingerprint on our solar system, proof that no world, no star is ever truly isolated. Over billions of years, the cloud stabilized. The collisions ended, the chaos faded, and silence returned. But it is not dead, it breathes slowly, its particles tracing immense paths through space. The inner region, perhaps a few thousand astronomical units from the sun, remains somewhat flattened, a relic of its disk-born origins. Beyond that, the orbits grow random and round, forming the great spherical halo that defines the outer Oort Cloud. Together they create a layered structure, a record of evolution frozen in geometry. Scientists estimate that the cloud contains 1 trillion objects larger than a kilometre, and countless smaller ones. If combined, their total mass might equal several times that of Earth dispersed across a volume so large that the nearest stars could pass through it without disturbing its symmetry. Each particle is both solitary and collective, a single note in the quiet music of the system's formation. Yet even as we model its birth, we must accept that no one has ever seen it. Its creation is known only through echoes, the trajectories of comets, the simulations of motion, the residual fingerprints of long-vanished events. To reconstruct it is to imagine a cosmic crime scene piecing together the orbits of the guilty from the evidence left behind. And what those reconstructions tell us is profoundly humbling. The Oort Cloud was not built by intention, but by consequence. It is the inevitable byproduct of creation, the debris field of planetary architecture. From a philosophical view, the cloud's origin carries a kind of symmetry that feels almost poetic. It is the outer mirror of the inner worlds. What was rejected became what protects. The same processes that threw matter outward to the edge of gravity also cleared the path that made life possible here close to the Sun. Without that great scattering, the solar system might have remained too crowded, too chaotic for stability. And without the cloud, perhaps the occasional cometary rain, the mechanism that delivers water and organics to rocky worlds, would never have occurred. Exile in this case was not punishment, but purpose. Each comet now sleeping in the Oort Cloud carries a history written in motion, a record of the solar system's birth. They are fragments of that original chaos preserved by distance. Every time one awakens and falls inward, it tells the same story in a new voice of collisions and captures of creation by scattering of gravity's paradoxical mercy. It reminds us that even in the act of being flung away, something can remain connected forever. The Oort Cloud is the outer memory of our system, a halo of forgotten beginnings, a fossil of the first dawn. It is both architecture and archive, both scar and signature. And though we may never touch it, its existence completes the solar system's symmetry, the quiet assurance that nothing born of the Sun is ever truly lost. One day, perhaps, a probe will reach its edge and look back. From there, the Sun will appear as a single, fragile spark in an ocean of black, a reminder that every star, every system leaves behind not only planets, but echoes. The Oort Cloud is ours, the echo of creation still drifting, still listening, still waiting in the dark. If the Oort Cloud exists here, it is unlikely to be unique. Nature rarely creates one-of-a-kind wonders. Across the galaxy, wherever stars are born in disks of dust and gas, the same forces play their roles again: attraction, collision, expulsion, capture. Each young star scatters fragments of its making into the dark, a shell of memory surrounding its light. And so, just as our Sun is ringed by its silent halo, other stars must be encased within their own. We call them exo-Oort clouds, the unseen echoes of distant creations. Their existence is still a hypothesis, but it is one of symmetry and inevitability. Every planetary system faces the same physics, gravitational scattering by giant planets, galactic tides, shaping orbits, the slow diffusion of debris into a spherical boundary. The blueprint is universal. Our Oort Cloud is not an exception. It is a sample, a single verse in a galactic chorus of frozen shells. We may never see these other clouds directly. Even for our own detection eludes us. Yet we may someday glimpse their traces, faint distortions in starlight, gentle fluctuations in microwave background radiation, or the ghostly passage of long-period comets from alien suns. Each clue would confirm that what began here is repeated everywhere, that the architecture of exile and preservation belongs to the cosmos itself. And if that is true, then every star in the night sky carries its own memory sphere, its own halo of ancient fragments still circling in darkness. Each one is a vault of origin, preserving what its worlds have long forgotten. Their invisible libraries drifting through the galaxy, holding the cold record of creation's first breath. From the fiery disk that birthed the planets, to the dark sphere that holds their forgotten debris. The story of the solar system is the story of motion and memory intertwined. The Oort Cloud is both the beginning and the end, the exhalation of creation frozen at the edge of night. It reminds us that boundaries are illusions. Even at 100,000 times the Earth's distance from the Sun, the threads of connection endure between the Sun and the galaxy, between destruction and renewal, between what we see and what we can only imagine. Perhaps one day we will send a ship to that frontier, a craft that sails past the last breath of solar wind into the quiet beyond. When it turns its camera back, the Sun will appear as a single glowing seed in the dark. And in that moment, humanity will see what the Oort Cloud has always known, that every light is surrounded by its own silence, every creation by its own memory, and that the dark itself is not emptiness, but continuation. Because in the stillness at the edge of light, the universe is not ending, it is remembering.